Hey, good morning, Algebra 1. It's Tuesday. It's Mr. Mays. This is for periods 1, 6, and 7. Yesterday, I posted up some worksheets for you, and one of them I posted looks something like this. Get you turned around here. All right, it starts off, sketch the graph of each function, give axis of symmetry, vertex, x-axis intercepts, and a y-axis intercept, and be neat when you graph this, all right? So the problem I want to show you guys is number 14. It looks like this, all right? So here's number 14. So Algebra 1, graphing quadratic function worksheet, this is number 14. So here's your challenge. You get to graph f of x is equal to 2x squared plus 16x plus 30, all right? Now you have several options here, but I'm going to start out with what I want, okay? And then we'll figure out the best strategy to get that. I want an axis of symmetry. I want the vertex. I want the x-axis intercepts. I want the y-axis intercept, and I want a beautiful graph. Now I've already done this problem and filled them in, but I'll show you how I got that, all right? So on the x-axis intercepts, you will find that if the parabola sits wholly above the x-axis and opens up, there will be no x-axis intercepts. If it sets wholly below the x-axis and opens down, there will be no x-axis intercepts. If the vertex sits on the x-axis, there will be one intercept. And of course, if the vertex sits below the x-axis, it opens up, you're going to get two. Or if it sits above the x-axis and opens down, you will get two. So on the x-axis intercepts, you may have none, one, or two. So keep that in mind. All right, so back to our problem. F of x is equal to 2x squared plus 16x plus 30. I started off, I identified my A, my B, and my C. Now you will note that C is where it will cross the y-axis intercept. If you put a 0 in for x, that would be 2 times 0 squared, which is 0, plus 16 times 0, which is 0, plus 30. So if you put a 0 in for x, it will cross the y-axis at 30. Remember, every point on the y-axis has an x value of 0. So to find the axis of symmetry, I took my A, B, and my C. And remember, here's your equation for the axis of symmetry. X is equal to negative b over 2a. I plug those in, negative 16, because it's the opposite. Okay, so it's a negative 16, and then 2 times 2, of course, is 4, and 4 goes into negative 16, negative 4 times. So the axis of symmetry is x is equal to negative 4. Now, we know that the vertex is on the axis of symmetry. So take that vertex value and put it in the x slot. Okay? Take the x value, put it in the x slot for the vertex. Now, you can find the y coordinate of the vertex right now if you want to. You simply plug negative 4 back into this equation, plug negative 4 in there, and you will find that y is equal to negative 2. All right? I'm going to do that a little later on after it's in a factored form, but you could do it now if you so choose. Now, to find the x-axis intercepts, remember, every point on the x-axis has a y value of 0. That's why we spent the time factoring and solving. So, let's take our original equation. Let's factor it. Remember, we always look for a greatest common factor first. And we have one. It's a 2. Rip it out. Okay? Everybody has a 2. Take it. So now you have 2 times the quantity x squared plus 8x plus 15. And I notice I can factor this. Factors of 15 that add to an 8 are 5 and 3. How about that? So here I'm in factored form. So f of x is equal to 2 times the quantity x plus 5 times the quantity x plus 3. Now, I don't like the 2. So I'm going to set it equal to 0, because again, every y on the x-axis is 0. And I'm going to get rid of the 2. I'm going to divide everything by 2. And when I say divide everything, I mean I'm going to divide both sides by 2. So when I divide by 2, that's what I have left. Now, I'm going to take each of these factors, x plus 5 and x plus 3, and I'm going to set them equal to 0. Again, every y on the x-axis is a 0. So when I do that, I get x plus 5 is equal to 0, x plus 3 is equal to 0, subtract 5 from both sides, subtract 3 from both sides, and x is equal to negative 5 and negative 3. So those are the x values of my x-axis intercepts. There they are, okay? So that's where it crosses the x-axis at -5 and at -3. Note that -4 is dead smack in between -5 and -3, and it had better be. Parabolas are symmetric. If it's not, you better go back and check your work. All right, so, and I already know what the y-axis intercept is. If I chuck a 0 in for x, the only thing left up there in the original equation is a 30, okay? And now I need a beautiful graph, okay? So I took all of this information, I came over here, and I plotted my vertex. I plotted my x-axis intercepts, okay? I didn't label them. It should be a -3, 0 and a -5, 0. But if you recall, you need 5 points to graph a parabola. So I need 2 more points. So I'm going to let x equal -6. I'm going to go on 1 past my x-axis intercept, and I'm going to let x equal -2. I'm going to go 1 to the left. I'm going to plug those values in, and if x is -6, y is 6. Pawang. Now this is symmetric, okay? If you went over from your axis of symmetry and folded it over, you would find you'd get a point at -2, 6. So there are my 5 points to graph my parabola. Now when you do number 14, that's what I want to see. Well, I want your graph to be better than that, all right? So I want to see a picture that looks like that. And I want to see this information clearly stated. Clearly stated. I want to see an axis of symmetry. I want to see a vertex. I want to see x-axis intercepts. I want to see a y-axis intercept. And of course, I want to see a beautiful graph. Okay. Wasn't that a hoop of fun? All right. That's what I want you to do. You got a worksheet out there. You got a couple of them to do. You've got a factoring worksheet, and you've got a graphing worksheet. And again, I want you to finish up section 8.5 and 8.6. I posted all the answers out there for you, so there should be no excuses. So please get them done, get them turned in, and let's get this ball rolling. And maybe Friday we can have a little, an event to say that we're done with chapter 8, and then we can move back into chapter 9. All right, that's all I got for right now. Maze out.